Lesson 1.1 is variables and expressions. And today you're going to interpret parts of an expression, such as terms, factors, and coefficients, and you are going to use the structure of an expression to identify ways to rewrite it. So in other words, you're going from English to math, okay? And then you're going to translate again from math to English, back and forth, okay? All right. On this page, you guys, I want you to go ahead and at the top of your, the next part of your spiral, I would like for you to write down your vocabulary words. You don't have to define them at this time. You will define them in the lecture, so you don't even have to leave space for a definition, okay? So, these are the words that we are going to cover in the section. All right, so today first thing we're going to do is we're going to be writing verbal expressions. We are going to write verbal expressions. So an algebraic expression consists of sums and or products of numbers and variables. There's your first definition. In the algebraic expression, 0.10d, the letter D is called the variable. And in algebra, variables are symbols used to represent unspecified numbers or values. And any letter can be used as a variable. T, X, C, whatever. Okay? So here are examples of algebraic expressions. Now you'll notice here for multiplication, you see when you put the numbers right next to each other, that means multiplied. Here, when you use the raised dot between the two terms, that's also multiplication. Now, a term of any expression could be a number, variable, or a product. Now, what a term is each one of these parts of the algebraic expression. So, this could be a term. This is a term. That's a term. Okay? Those are all terms. It's each part of the variable expression. Okay? Now, here, the term that contains the X or other letters is sometimes referred to as a variable term. Okay? So the variable term is the one that contains, obviously, the variable. Okay? The one that has no variable, that's called a constant because it doesn't change. And the reason it doesn't change is because it doesn't get multiplied by a variable, which could be any number. Does that make sense? Okay? All right. In a multiplication expression, the quantities being multiplied are called factors. Okay? And the result is a product. So if I go back up here and look at these, if I look at 4CD, 4 is a factor, C is a factor, D is a factor. Once you multiply those all together, you get the product for CD, whatever the C and the D might be. Here, we have two terms for 2x plus 4, but this term has two factors. It has a 2 and an x. Is everybody clear with that? Do you see how you can determine what the factors are? All right. Still pretty much a review, right? Okay, so going back down here. When we are multiplying, okay, here's one way that you can show multiplication. You put the two variables or the two terms or the two factors right next to each other. If we had numbers, we wouldn't put them right next to each other, right? Because if I had 2 times 3 and I did it in this first format, what would it look like? 23, right? So you don't put those numbers together like that. You could also use the raised dot to show multiplication. showing multiplication with parentheses. Either one or the other, or both of them. Okay? Now, an expression like x to the n power is called, it's called a power. The reason is because it's raised to an exponent. And the word power can also be referred to the exponent. Okay. So let's see. The exponent, of course, tells us the number of times the base is used to multiply the factor. Okay? So if I had 3 to the 4th power, that's 3 times 3 times 3 times 3. All right, example 1 is writing verbal expressions. So we're going to write a verbal expression for 8x squared. What's another way that you can write 8x squared? 8 times x squared. The way that you could write was, let's say 8x to the power 2, right? And there could be several different ways that you can write this, okay? How about writing a verbal expression for this? I'm not going to take away one of yours. What's another way I can write that expression? Very good one. Yes?
9 to the power of 5 minus 16 times y.
Yes. That's good. Anybody have another one?
5 to the 5th power minus 16 y.
You know what you just said?
What?
You know what you just said? All right. So here, the difference of y to the 5th power and 16 times y. All right. So take about 2 minutes and do this example 1a and 1b. All right. So for the first one, we could have 16 times u to the 2nd power minus 3. That's what one of you said, right? Then, for the second one, 1/2 of a plus the quotient of 6 times b and a number. When we write algebraic expressions, another important skill is translating verbal expressions into algebraic expressions. So that way, that is translating English to math, okay? When writing an expression to model a situation, you begin by identifying the important quantities and their relationships. So you need to look, when you are looking at, when we're translating English to math, you have to see what words tell you what operations. And here are some of those key words, okay? We've got more than, sum, plus, increased by, and added to. And you can read the rest of those. All right. Algebraic expressions. Writing algebraic expressions. When we want to write an algebraic expression for 5 less than a number c. 5 less than a number c. Now again, when we're going from the words to the math, okay, we're just translating to the algebraic expression. So what words in there tell me the operation? So look here, less than suggests subtraction. You got to be careful though, because sometimes less, you'll have the words less or less than, okay? So in this case, it says 5 less than a number c. So we have our number c. We have our number c. Less than, actually less 5. That means subtract 5. Now let me ask you this. If it said a number c, let's see. If it said 5 less c, what what would that be? If it said 5 less C, it would be 5 minus C. Do you see the difference between the less and the less than? Okay? That kind of tricks people up sometimes. Okay? All right. So how about this one? Write an algebraic expression for 9 plus the product of 2 and D. Okay, now plus means add. Product means multiplication. Very good. So here, how are we going to write this? 9 plus the product of 2 and D. What do you think? Anybody, just spit it out.
9 plus 3.
Very good. 9 plus 2D. Is that the only way I can write it? Nope. I can flip it around too, right? Uh-huh. 2D plus 9, right? Even still, it's the product of 2D, 2 and D, and the sum, they're going to add that to 9. Is that clear? All right. Write an algebraic expression for 2/5 of the area A. 2/5 of the area A. And again, we just talked about this. Of here means multiply. And we're going to multiply the area A times 2/5. So this would simply be, 2/5 times the area A. Right? All right. Good. So I would like for you to take a couple of minutes to do those. Who's got one for 2A? The product of P and 6. Who's got one for me? The product of P and 6. Logan? Okay. Just the P next to the 6, right? So, which one do we put first in algebra, thing? The number goes first. That's called the coefficient, right? So, we've got 6P. How about 1/3 of the area A? Very similar to the other one. Yes. 1/3 A. And that's all there is to it. Is that right there? Pretty simple, right? All right, let's see. All right, variables can represent quantities that are known and quantities that are unknown. They are also used in formulas, expressions, and equations. So here, in our real-world example, it says Mr. Nehru bought 2 adult tickets and 3 student tickets for the planetarium show. Write an algebraic expression that represents the cost of the tickets. Okay. First, what is the variable? What is the thing that changes all the time? We can say the adult ticket's going to be A, right? Okay. A is equal to the adult ticket. Okay, and we always want to identify our variables. We always want to define our variables. And then for the student ticket, let's call it, okay. Equals.
Attention, for.
Okay, so how many tickets did he buy? How many adult tickets did he buy?
2.
So he bought 2 adult tickets, and how many student tickets did he buy? He bought 3 student tickets. So, using these variables, what will my algebraic expression be?
2A plus 3x.
2A plus 3x. Is everybody clear? All right.